So it looks like this is going to become a part 4 video. I wasn't expecting to do 4 parts on this video, but I've discovered an issue with this where it's not quite right. It's mostly perfect, apart from one thing. I'm trying to calibrate the 1.9 milliamp range, and I can't tune it down. So this is the lowest I can get it, is 1.903. Now there's an adjustment just here, which is normally covered under shields, taking my shields off right now while I'm working on it. That one there, that's R303, and you should be able to tune that to get exactly the right value, which is, this is actually a gain adjustment for the ADC. That's what that actually does. So it actually puts a voltage through to the ADC. It's a plus and minus, so it goes between minus 15 volts and plus 15 volts on that adjustment. And I've actually measured on a resistor just here, which I'll show you in a second as well, to verify that adjustment's working correctly. It is indeed swinging plus and minus, so it's like it's got like an open trace or something like that. It seems fine. I can't get the adjustment down. So right now this is turned fully anti-clockwise, right, which is the lowest current it will do. I'll turn it clockwise, it goes up. So fully clockwise goes 1.9111 milliamps. Fully anti-clockwise goes 1.90378 milliamps. I can't get it right down. I was thinking, oh, maybe there's an error in the offset or something, so it's like it's not dragging the right way. So I checked the power supplies, and the positive power supply is sitting a little bit low. It's sitting at 14.4 volts instead of 15. I'll show you that. So there is the positive rail, 14.4. So it's a bit on the low side. That comes off the bottom board, the actual digital board on the bottom. That's where the regulator is for that. You've got two regulators that are back to back. Those are the plus and minus 15 volt regulators. That rail's sitting a bit low, which is a bit concerning. If I probe here again, there it is, there's the negative rail. So negative is minus 15.2. So what I actually did is I strapped my power supply here across that rail and injected a higher voltage to try and take over from the regulator on the bottom board. So I dragged the voltage up. Now it did actually affect the current very slightly. It did improve it slightly, but nowhere near to the degree it needs to be improved by. I only changed it by about 100 nanoamps, increased it by. It wasn't really much. I showed a meter, hold on. 1.903 is what we're getting, with it turned all the way down, and as I turn it all the way up, we get to that. Okay, so it definitely isn't right. In fact, it's turned right down. The actual resistor, unlike all the other ranges, doesn't have an adjustment, because they only have the gain adjustment for the 1 milliamp or 2 milliamp range if you want to see it. They call it 1 milliamp range, but it's actually 2 milliamps because that's the scaling. There's no other adjustment for this. That is the only one. All the other ranges, obviously based off the gain adjustment initially as well, you have to get the gain adjustment right. That's one of the first calibration steps, is to adjust that, get that gain down, get that set correctly for this range, and then you go through and tune all the other ranges up. So if this is set wrong, or you change this one, it affects every range. There's no adjustment for this. So just down here, I'm going to point to it with this, all these position resistors in here. That middle one there, that black one, that one there, 4.93k, measures perfectly. That is the resistor which does the 1 milliamp range. Every other resistor in here has an adjustment. Not that one, because like I said, they figured that you do the gain adjustment in the 1 milliamp range, and that sets it. But I can't actually find a reason for it to not be working correctly. The voltages, although I tried, messing with it, it is okay. That's the 15 volt taps there. Test points of 15 volt rail, so just there. That's what I was checking on. I don't see a way of getting this value down. I don't actually know why it's wrong. I measured that resistor and it's fine. It's 4.93k. It's perfect. So one of the things I tried, which you can kind of see I've done here, is I've got my resistance block here. So I set this up, set up to 1 meg ohm, put that in parallel with that resistor to see what changing the value would actually do. And reducing the resistance increases the current. So there needs a higher resistance. So it could be possible to lift that resistor and put another resistor in series. This is a small one. It wouldn't take much, I don't think. I can actually lift it and use this in series and work out what resistance it needs, and try and get it so maybe I've got an adjustment on here, and maybe bring the gain adjustment back to center like it should be, probably. Put that to center, tune that resistance so it's correct, and then put a series resistance there. Now I don't have any precision resistors like this. I've only got standard ones, so If I do modify that, I'd be potentially reducing the accuracy, but right now it's way off, so you know, temperature coefficient would be the main thing. But if it's only a really small value resistor, like, you know, if it's say, like, for example, 50 ohms or something, although it's going to vary a bit with temperature, it shouldn't have that big an effect, and it's still going to be more accurate than it is right now. Yeah, so right now I'm kind of torn about how to resolve this, because I can't actually see a fault. The voltage in here looks okay, that resistor looks okay. I mean, it is switch bus and JFETs. Maybe that's related. Could be a JFET's a bit dodgy, but then it means it's giving a lower resistance, not a higher one. Yeah, that doesn't really make sense. So you expect a JFET to maybe increase in resistance, which means it'd go lower current, not higher. So that doesn't really work. There's a JFET pair, maybe because maybe it's doing push-pull. I'm not quite sure how it works. I haven't scoped or anything like that, but I don't know. I can't actually find a fault apart from the fact it's wrong. So if I probe there, resistor there, which is what goes to the wiper of that. So you get 14.4 because it's turned fully in one direction. And if I go to the other resistor, which is what's heading towards the ADC, get 278. It goes to a voltage divider. There's another resistor for that, 278. And the other end of that resistor, just here, 0.157 or 0.0157, that goes to pin 23 of the DAC, just here. Right. So that's what the DAC is getting on that gain pin when it's turned fully in that direction. Where's my adjustment gone? Where's my screwdriver gone? I've lost it now. There it is. And if I turn it all the way the other way, which is going fully negative to minus 15 volt rail, we'll do the same measurements again. Now you've got minus 15.2 in between those two resistors, minus 2.93. At the other end of that resistor there, which should be the same as pin 3 on the DAC, so it's 0.086 or 0.086, and on the DAC 0.0086. Right, so you can see it is swinging plus and minus around the 0 volt rail. So I think that adjustment is working perfectly. It just isn't working the way it should. I'll just turn the output off so I can measure across this resistor. Otherwise there's voltage across it. 4.937. Perfect. So there's the ADC right there. I've just found a data sheet for it, so that's great. Managed to find one, even though this is an obsolete device officially. So pin 23 is getting that. And if pin 24 is 6.33 volts. Now this is an internal reference in the ADC which is built out to that pin. It's supposed to be 6.3 volts within 1%. So if that reference is wrong, could that be causing a problem? Because that's part of the circuitry. That gain adjusts the reference adjustment. That's what it's used for. I mean, that 6.33, I mean, that's within spec. That's like 0.5. So that's in spec. So it's not like the reference has gone out. Now apparently it's also fed back into pin 16. So it'd be 13, 14, 15, 16. That'd be 16 there. 6.33. So that's there too. So I can't fault it yet. So let's go check the JFET side of things. U317, which is that chip right there, that controls the JFETs. So let's just check the actual signals levels going to the JFETs. So I just want to do a comparative check to see what we're getting in case in different ranges it's changing, because that might give us a clue that maybe there's a JFET issue. So I'm going to rule that out. So pin 14, which is that very corner pin there, 9.26 volts. Call it 9.27. Alright? That's what's powering the JFET to 1.9 milliamp range. So if I change this to be 1 milliamp, 19 milliamps, it should go the next range up. I'm looking at the camera what I'm doing, so hopefully I'll get this right. 19 milliamps. So pin 14 should now be different. Yep, 15.2, and then 13 should be that one. There you go, it's 13. 9.7. So there is a difference. So we get 9.7 on that one. Let me check another one. Okay, let's check the next scale down instead. So this should now be off on pin 14. It is. Pin 13 should be off. Yes, and pin 1 should be on. 9.2. Okay, that's comparable. And that's given the correct current reading as well. That one reads correctly. Okay, so I think that reading there is interesting the way it's scaling as well. I wasn't expecting it to be scaling. Now it is kind of linked to the reference. So maybe that's part of that as well. Yeah, okay, let's try something else. Back to 1.9. Exponent 3 again, so back to where we were. That's reading correctly, as expected. So pin 14 should be 9.2, yes. Okay, let's try something. Let's see what happens when we drop this down very slightly to try and get the correct reading. So if I go 1.897, let's try that. I've now got 1.9 milliamps coming out. The voltage has dropped slightly. 9254 now. So it's still actually slightly high, but as close as I'm going to get, I think. So yeah, so that is now reading 1.9 milliamps. So it's 9.254. Go back to 1.9 again. Yeah, so it is indeed scaling. So that needs to be about 15 counts lower than it is. So the JFETs that control this are all right here. So we've got a chip there, we've got a resistor pack here, we've got the JFETs. So this JFET here, if you can see, second one down, just there, that's the one which is controlling that range. Right, so all the others are off. Okay, just checking them all. There's no leakage. So when they're off, they're minus 15 volts. 9.2 as well on that one. Interesting. Oh, that's right, as a pair. So off again. Right, so these two are the same thing. Let's just stick there and there. So 9.35 there, and this one I think will be the same because I think they're in parallel. 9.30. It's interesting, there's a slight difference. I might check into that one. And then into that connection there, 9.304. 9.303. There's a very slight difference between these two, is interesting. 9.35, or call it 36. Check that one again. 9.30. That's interesting. I would have thought they'd been about the same. You couldn't see any of that because I too zoomed in. So, yeah, we've got these two parallel here. .36, 9.30. Let's check that. That's fine. It's because it's bootstrapped with some other transistors, so the main control logic comes in, and so it does have a 100k resistor between them. So I think that's alright. So that change in voltage we could see, that is actually partly linked. Well, it's kind of linked back to the reference. It comes from the ADC, sort of DAC. That goes through some buffers and stuff like that, and it links back through and comes into those JFETs. But it's also got these other two transistors here, which are like driving transistors. They're also linked to it. So it kind of comes in, goes through that stuff, then goes through all these resistors after going through those JFETs. If that resistance is too low and all the ranges are okay apart from one, it almost makes you think the only thing I can really do to solve this is to change that resistor. It seems odd that it's like it now, where it's obviously always worked, and I can't find any actual faults. It all seems okay. You think if it was a JFET going higher resistance, then that would make that go the opposite direction. It would go higher, go lower, not higher. I'm a bit confused by this. I'm not quite sure why it's different to what it should be. Maybe it's always been wrong. Right, so I've just lifted that resistor. I've put my resistance box here in series. The current's already dropped a little bit just from the resistance box. Switch resistance. Go by 1 ohm up. Yep, okay, that's looking pretty good. Oh, that's too much. Okay. So, literally, it's ohms. It's literally a matter of ohms. So that is 7 ohms. Plus the box resistance, which I think is about an ohm or so. Not sure what it is offhand. Yeah, so 7 ohms. So if I were to go down by 10 ohms and then bring the gain up, that would give me adjustment range. Hopefully, let's have a look. This will miss out all the other ranges. Let's have a look, see if I can adjust it. Yep. Okay, cool. So if I put 10 ohms in there, that would actually be, I don't know, maybe a quarter of the way up. So if I went, so halfway's there, that's midpoint there. So 20 ohms is too much. So midpoint would be, yeah, about there. So that is 17 ohms midpoint. So if I say a 15 ohm resistor, which I probably do have, that would be really close. Now the only question is that going to mess up all the other adjustments too much? If I set it there like that, if I adjusted that quickly there, and let's just try some adjustments here. Let's do exponent 6. That's increased in current, but that's by the same amount the other one was out by. Okay, so that one there is all the way up. That is almost all the way up. That's the 100 milliamp. So I can't really turn that one down. That may not matter. That could come down. The next one down is 20 milliamp. That's just over halfway up. Next one's in the middle. That's 200 microamps. Next one is almost all the way down, so it can come down. That's 20 microamp. Those other 4 in the center. So that's the 2 nanoamp, 20 nanoamp, 200 nanoamp, and 2 microamp range. Okay, so that's actually looking promising. If I stuck a 10 ohm in there, that would probably be close enough. So it's on 10 ohms now. Let's try this adjustment, because that way at least I won't throw the other ones out too far. As long as I've still got adjustment range. Yeah, it's not much adjustment range at 10 ohms. A little bit, almost none. 10 ohms is there. That's hardly anything. It's not really enough. Of course I'm doing microamps right now, not milliamps. 9. Oh, I think I might be on the wrong thing anyway. Exponent 3. I'm doing milliamps, not microamps, right. So it is messing up that a little bit, but if I set that there and turn that one up a bit more, they can all be turned down a bit apart from the 100 milliamps. That can't be turned down. So 100 milliamps can't be turned down. Let's just have a look at the ones which can't be turned down, see if I can still get in the range. So 100 milliamps and 20 microamps can't be turned down. They're the ones at the limits. So let's just see what we can do there. So let's do 20 microamps. Let's go 19. Enter. And exponent 6. That is, yeah, that's reading high there. So I'm just trying to decide if as long as it's within adjustment range, it's fine. I mean, part of this is probably because of component aging and things like that, you know. So that's now 19 microamps, just fine. Using that adjustment to try and do that. Let's do 100 exponent 3. That's there. If I turn this one down, can I get it? No, I can't. So I can't even get that one down. So this does kind of need to be, yeah, this does almost need to be right down to nothing. Well, I've just put in a 7 ohm metal film. It's supposed to be 6.7. I'm not quite sure exactly what it was, but it's about then. Being such a small value, temperature coefficient is going to be less important. I should have a much smaller effect. So it shouldn't really be so bad, you know, even not being such a good resistor. It shouldn't be such a big influence on it. If I was changing the whole thing to like a 5k, that would be a big difference. That would be a problem then. But because I'm only doing a really small proportion, it will probably be okay for temperature coefficient side of things. So I hope so anyway. So let's do voltage, 30 volts again, and current 1.9, and exponent 3, and turn the output on. What do we get? 1.898. Now I've just soldered it, so it's still cooling down a bit as well. That could well affect things. It's drifting upwards right now, so that's probably a good thing. It's way closer than it was, but just in the opposite direction. So if I increase it slightly here on the gain, up at 899, I'd like to try and get it tuned in, but it might be too big a value. I might have to be a bit more picky about which resistor I use. I'm changing this by quite a bit to get it there. Alright, that's within 10-15 counts right now, and obviously it'll still be stabilising from the heat that I put into it. There you go, now it says 1.9, and it's still changing. So let's just drop it back down a little bit. I think this has gone a bit too high for my liking, so let's just do 100, which is the one which I was worried about, and 100 milliamps. we'll see if we can get that one tuned down. No, I can't turn that one right down, so that's now gone too high instead. So I wasn't happy with that adjustment on this thing with that resistor in there. I mean, yes, it worked, but I was right at the end of the adjustment ranges, and I wasn't happy about that. So it made these other adjustments harder to get. Well, they could do it, but they were only barely there. I wasn't happy with that. So I'm thinking I'm going to come back to this and go back to the gain adjustment here. I'm thinking the gain adjustment is what probably needs tweaking, really, in reality. Although it seems like it's adjusting correctly, it all looks fine, it isn't. It's just not sitting right. I wanted a bit of a play with it just now to see what would happen. If I bridge out R3 something, whatever it is, the one that's just here, R301. If I bridge out R301, I was using my box here, I tried different resistances, and about 500k or so, 400 to 500k, works quite well. So it gives me some adjustment range on here. Right, so I'm just slightly round. So it's still very low, but the fact this has now shifted the range down slightly means I should be able to get more on these adjustments, and hopefully still be okay with everything else. So I'm going to solder in a 470k across there, readjust and see if it's good enough then. So that might be what I need to do, but the fact that it's actually shifted from factory is still concerning. I don't know why it's shifted, but when I get this thing tuned a bit better, I'll show the voltage again. You can compare it to what I got before. Basically what it should do is give this trimmer more influence over the ADC. It'll put slightly more voltage through into it. So that's the idea of that, because it's basically a divider here, voltage divider going into the ADC. And what I'm trying to do is put slightly more in, so it's got slightly more influence to bring that range down a bit further. That's what I'm trying to do. Alright, let's find out what we get. Put that resistor on there. Haven't set it for anything particular right now, I'm just looking at it. So 40 anti-clockwise, so getting 0.022. We're getting 0.016 before, weren't we? Something like that. And 40 clockwise, getting 0.017. I think we're getting 0.0082 before, weren't we? So we've definitely given it a lot more influence. So let me just adjust this now for the 1.9 milliamp, and let's see how we go. Getting 1.898 in that current position. Let's just adjust that to be the correct one. I'll have to obviously do this again later on once it's got the shields back on again and it's all warmed up. But this is going to be a ballpark adjustment right now. Yep, I can get that easy. And obviously it's going to be slightly more touchy because I've given it more influence. So the range is going to be broader. That's the trade-off. That's exactly 1.9 milliamps now. It's drifting a little bit because of, you know, warming up and what have you. But okay, that's there. So that's fine. I can adjust 1.9 now. Can I do negative 1.9? I reckon I can get there. This would have changed all of the adjustments. So every single one of them would be different. Negative is that one there. So I quickly look at all these and see if I can get all the adjustments where I need them to be. Otherwise, it's a waste of time. Yep, I'm getting negative 1.9. I can get to that. That's there. Great. Let's do 19. Yeah, I forgot which order I have to go in now. I have to find a calibration page. I don't know if it's 19 or 100 next. Anyway, do 19. I'll go through these again properly afterwards anyway. Proper calibration. 19 is that one there. Second one over. So that one's going to be okay. So 19 is there. 100 is right at the end of the limit, so should make the second alignment a bit easier if I can get it closer now. Right. Okay. Let's do 100. Sitting slightly low, which means I can bring it up, which is perfect because I needed to bring it up. Yeah, that's much better. Much better. Before I was almost out of adjustment with that. Okay. Take that away, maybe better see. So previously that adjustment there was right in the limit. So it's now facing across. Before it's facing like the way. It's come around like a quarter of a turn now, so that's much better. So before I forget, let's have a quick look at this voltage on the ADC at the 1.9, that one there. What we're getting now with it tuned to where I need it. So that's just outside the range I could get before. Something I think this should have actually had from the factory is multi-turn trimmers, because these trimmers are really, really touchy, even before I've done this. So that isn't helping. It's making it really hard to get these adjustments really precise. If they had multi-turns, it would have been far easier, I think. I mean, these are probably high quality trimmers you know, low temp code kind of thing, I expect that's what they are. So it's probably limited availability and choice to them. I think multi-turn would have been easier to set. It's just very, very touchy. Slightest little touch. Even just resting this on it will change the value, you know. Yeah, it's touchy. So I'm just twiddling with a screwdriver. I've done the alignment on this thing now. I was able to get all the alignment adjustments correct. As expected, because I adjusted the gain, I had to adjust every single trimmer. When I did this alignment previously, I didn't have to adjust all the high sensitivity ones, which are like the Bank of Ford just here. I didn't have to touch those ones. Those ones are basically right. So it's like all the Exponent 9 type here, they're all fine. So that's like nanoamps ranges sort of thing. So those were okay, but this time because I adjusted gain, I adjust everything. But that's fine. Now I've got this Keithley DMM 7510, which I've been using for this. I was showing that in the previous video. The align procedure requires you to hook this up to a resistance, a fixed resistor, which you know what that is, inside a shielded box and that sort of stuff. So you can measure the voltage off that to work out the current going through the resistor. This DMM 7510 can just work out the current directly. I don't need to do all that messing around. I can just plug it straight into the front and that'll tell me the current within, you know, decent accuracy. I'm pretty happy with that. It's working okay. It seems fine. So now I've done that small change with adding that resistor across R301. I think it's R301, wasn't it? I've gone to give that gain adjustment more swing. That's working fine now. Why it shifted from factory, I'm not sure. Maybe the ADC's aged a bit. Maybe one of those resistors has gone higher in value and it's causing it to shift a bit. It is a resistor divider, so maybe one of those has shifted a bit. But I mean, they look like high quality resistors, so I don't see why it would. It's not like it's carbon composite or something like that, which would often drift. Yeah, it's done. I'll put screws back in it now. That's one completed piece of disc gear. Happy with that. 4-part video. Ended up being more than I thought it was going to be, but anyway, that's how we go. Just go over there, if not already subscribed, you can buy me a coffee. You can also support me on Patreon over there to help me buy things like this, do videos about. Catch you later.